Hello everyone and welcome to week 6. Like I said in the week 5 video, this is a very short week, so be sure to check your schedule to make sure we get everything turned in on time. No late assignments will be accepted in week 6. I hope you all have had a very good session. I've enjoyed being your instructor, and let's get started with the week 6 video. Alright, we're going to be comparing two types of interest this week: simple interest versus compound interest. And let's quickly take a look at the differences in between the two, or the difference in between the two. With simple interest, your interest is calculated on your principal rate every year. So whatever your initial principal rate is, your interest will be calculated on that initial principal every year. For example, if I had $500 invested in something at a rate of 10% per year for 2 years, with simple interest, the first year my interest would be the 500 times the 10%, which would be $50 in interest. The second year my interest amount would be the same initial principal times the 10%, would be $50 for that year and for each year on. So totally I would have the initial 500 plus 50 for the first year plus 50 for the second year for a total of $600. So simple interest is calculated on the initial principal, and that's it. Year after year is calculated on the initial principal. Compound interest is a little different. It's calculated on the first year on the initial principal, but each year afterwards is calculated on the initial principal plus the previous interest earned. So for example, with that same $500 at a rate of 10% for 2 years compounded, first year I would still earn $50, but the second year my interest will be calculated on the initial 500 plus the $50 that I earned in the first year. So for the second year my interest will be calculated on $550 at 10%, which would be $55. So this would give me a total of $605, which is a little bit different than simple interest. And for larger amounts of money and investments, it'll be a lot different. So that's the difference in between simple and compound interest. Okay, so let's start off by looking at the simple interest formula that we're going to use. The interest amount equals the principal times the rate times the time, and we use I equals P times R times T. Now in this video I only use R because I'm going to go ahead and convert whatever my rate is, percentage rate is, into a regular number. And remember, we do that just by dividing by 100 or simply moving your decimal 2 places to the left. For example, if I had 5% interest and I wanted to convert that to a regular number, I would divide 5 divided by 100, which simply moves my decimal 2 places to the left. And if it starts in front of the 5, move it 2 places to the left. That would be the same as 0.05. Or 37% interest if I move my decimal or divide by 100. That would be 0.37. So as we go through the video, when I fill in my formulas, I'll go ahead and convert my percentages into a regular decimal number. Okay. So starting with this one, John took a loan of $5,000 at the rate of 5%. After 3 years, what is the interest that he had to pay? Alright, so he had an initial amount of $5,000. That would be the principal. Sorry about that. So the $5,000 would be the principal. Then he had an interest rate of 0.05 and a time of 3 years. So what is the interest? Well, all we have to do is plug into our formula. Interest equals the principal rate, principal amount, times the rate, and 5% again is the same thing as 0.05 times the time of 3 years. And we would just multiply those three numbers to find that he would make about $750 in interest. So again, we just fill in our formula, principal times rate times time, and we multiply the 3. Okay. Christina borrowed $10,000 at 8%. If she paid $2,000 in interest, how many years did it take her to pay the loan back? This time my principal amount is $10,000. The interest rate is 8%, so that's the same thing as 0.08. And this time the problem gives us that she gained $2,000 in interest, and we're looking for the time. Therefore, if interest equals principal times rate times time, I can rearrange this equation by trying to isolate the time, and that will be the same thing as time equals interest divided by principal times rate. So I can set that up as time equals the principal divided by, sorry about that again, let's see here. Let's try that again. Time equals the interest, which is $2,000, divided by the principal, 10,000, times the rate, 0.08. So the first thing I would do is to multiply the 10,000 times the 0.08. And when we do that, we get 800 there. And then we would do 2,000 divided by 800. So 2,000 divided by 800 will give us about 2.5, which means that the loan was for about 2.5 years, 2.5 years. So we just rearrange the equation for time equals interest divided by principal times rate. We multiply the principal and the rate, and then we divide. And we find that the time of the loan was 2.5 years. Okay. All right, let's take a look at this one. Kiara invests $3,000, there's your principal, into a fund that earns simple interest of 7%. The interest is payable after 4 years. What is the total amount that she will receive at the end of 4 years? So it's just first of all, we need to calculate the amount that she's going to receive in interest. But the question asks for the total amount after 4 years, so to fully answer the question, I will have to answer or add the principal plus the interest to find the total amount calculated after those 4 years. So let's calculate the interest first. So we have interest equals 3,000 times 0.07 times the time of 4 years. And that gives us a total of $840 when we multiply those three out. But again, the question asks us for the total amount that she will have after the 4 years. So we would have to add the principal, the initial principal, the amount she invested, plus the interest that she earned. And when we do that, 3,000 plus the 840 will give us a total of $3,840 after 4 years. So again, be careful and make sure you fully read the questions to see what they're asking. If it says total amount, that means that you would have to add the interest to your initial principal to calculate the total amount earned. Okay. All right. John traveled a total of 900 kilometers. He covered 65% of that by plane and the remaining distance by train. How many kilometers did he cover by each mode of travel? Well, we can find the amount covered by one form or the other by using amount equals the base times the percent. So let's find the amount he covered by plane first of all. We know the base or the total amount was 900 kilometers, and the percentage of that by plane was 65%, which again is the same thing as 0.65. So multiplying that out would tell me that he covered 585 kilometers by plane. But it said by each mode of travel, the question asked. So we have the plane portion of it, but I also need the train. Well, if we know that he covered a total of 900 kilometers and he covered 585 by plane, then the amount by train, all we would have to do is subtract those two to find out what's left. So when we subtract those two amounts, we find out that 900 minus 585 would leave him 315 kilometers to travel by train. So again, we took the base. We knew the percentage of the plane, so we took the base and multiplied times that percentage to find that he traveled 585 kilometers by plane. And then we subtracted that from the total to find out what he traveled by train. Okay. All right. Compound interest or growth. We use the same formula for compound interest and growth. The formula is amount equals the principal amount times 1 plus the rate times the time. And you'll see it as A equals P times 1 plus R to the nth power. That should be to the time power. So this N represents time, whether it's so many years or so many months or so many minutes. That represents time, and it's an exponent. Okay, some key phrases to help us know that it could be compound interest or growth. Grows per minute. That per minute there would give me a clue that that's compound interest or compound growth, or increases so much amount per year. That would give me a clue that that's compound interest or compound growth. Okay, so let's look at a few of these problems. A bacteria grows at the rate of 30% per minute. If its population is 250 initially, what will its population be in 4 minutes? So we have a compound growth problem. We have a growth problem. And the formula we're going to use is A equals P times 1 plus R to the nth power. And we know the rate to be 30%, so 0.30. We know the principal amount is 250. And we know the time, which N represents time, is equal to 4. So let's find out the amount that the bacteria will be after 4 minutes. So we'll replace P with 250. Then we'll always have 1 plus the rate, 1 plus 0.30, and to the nth power, and again that's the time that goes up there, and that is an exponent. So the first thing I'll do is add the 1 plus the 0.30, so that gives me 1.30 to the 4th power. Now I have to take care of this exponent next because my order of operations tells me to do so. And remember, the exponent tells us how many times to multiply the base times itself. So that means 1.30 times itself 4 times, because we had an exponent of 4. So that's really 250 times 1.30 times 1.30 times 1.30 times 1.30. And we would multiply that all the way out to come up with our final answer. And we find that that should give us about 714.025. And we'll say that the bacteria grew to about 714. So you have to be careful with that exponent and take care of that exponent or expand it out like I did there. The exponent tells you how many times to multiply the base number times itself. Okay? Alright, let's look at another problem that's similar to that one. It says a business expects to increase its output at the rate of 6% per year. If the output for the business in 2008 was 5 million, what would the business expect the output to be in 2011? So we see that we have a rate of 6% per year, and it's going to span over a 3-year time from 2008 to 2011. And the initial amount was 5 million. So we have the rate of 6%, 0.06, the principal of 5 million, and the time of 3 years, or n equals 3. So we're trying to find the amount after those 3 years. And we need to add a p there. So it should be a amount equals the principal, which is 5 million, and we're just going to call it 5 for right now, times the rate, or 1 plus the rate, to the third power. So 5 times 1 plus 0.06 raised to the third power. So we'll add 1 plus 0.06 to give us 1.06 to the third power. And then let's expand that 1.06 to the third power out. Again, that means that we're multiplying 1.06 times itself 3 times because we had an exponent of 3. And then we will multiply 5 times 1.06 times 1.06 times 1.06 to come up with the amount of about 5.96. And remember, we were dealing with millions, so I need to add the word million to the end. 5.96 million after the 3 years. So again, we just fill in the formula, principal times 1 plus the rate raised to the nth power. Okay. All right. Let's look at depreciation. The formula is very similar. Depreciation means that the value is going to go down over time. So instead of saying 1 plus the rate here, we'll have 1 minus the rate. But the formula is essentially the same as compound interest or growth, except we're going to have 1 minus the rate here because the value decreases. Okay, so the value of a property declines every year by 8%. At this time, the value is $125,000. What will the value be 3 years from now? So the property is going to depreciate every year over 3 years. So let's look and see what the value will be after 3 years if it depreciates by a percentage or at the rate of 8% each year. Okay, again, I need to add that principal there. So we have principal times, so the principal was 125,000 times 1 minus the rate, 0.08, raised to the third power. So that's 125,000. 1 minus 0.08 will give us 0.92 raised to the third power. Now again, like in the problems before, we need to take care of the exponent. That exponent is telling me that I need to multiply 0.92 times itself 3 times, because this is an exponent of 3. So I can expand it out like that, and then multiply 125,000 times 0.92 times 0.92 times 0.92. And when we calculate that value, we find that the house value will be $97,336 after 3 years if it depreciates 8% each year. Okay, well, again, the difference in between simple interest and compound interest is simple interest is calculated on the initial amount or the principal year after year after year, and compound interest will be calculated on the principal plus the interest that has been earned in previous years or months or whatever the period is. So that's the difference between simple interest and compound interest. I want to say congratulations, you've made it to the final week and you've made it through the course. I wish you well on this assignment and this week, and I wish you well in your final exam and in your future endeavors. Thank you for letting me be your instructor in this course, and have a good week.